Welcome to FYI, the For-Your Innovation podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARK Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARK. All statements made regarding companies or securities are strictly beliefs and points of view held by ARK or podcast guests, and are not endorsements or recommendations by ARK to buy, sell, or hold any security. Clients of ARK Investment Management may maintain positions in the securities discussed in this podcast.
Hello, and welcome to FYI, the For Your Innovation podcast. From ARK Invest, I'm Brett Winton, ARK's chief futurist and the host of FYI. With me today, I have Frank Downing, our director of research focused on AI, and we have a great conversation today with Frank. Who are we talking to?
Manu Sharma. He is the founder of Labelbox, which is a company you can infer from the name that labels data. They were founded in 2018, and I think the industry has changed a tremendous amount since then. It's the third time we've had him on the podcast. In 2019, the business really looked a lot like labeling images for self-driving systems, for example. So you get an image, you have a low-skilled worker that can say, this is a stop sign, this is a red light, this is a green light, etc. We checked in 2022 and GPT-3 was out, but it was the month before ChatGPT came out. So things in the generative era were starting, but in the early days. And then this conversation that we just had with Manu goes much deeper on how everything has changed since the ChatGPT moment.
Yeah, it's a fascinating conversation. I'm sure you'll enjoy it. Let's talk about AI and kind of set it up a little bit. Like, what do we think is going to happen with AI over the course of this decade? Not like everybody's talking about, oh, well, there's a lot of NVIDIA chips getting purchased and we don't see a lot of revenue coming off of kind of AI software. But what direction is the industry heading?
Yeah, I think we talk about this a bit in the podcast, but Sequoia calls it the $600 billion question of AI. You know, all this hardware investment, where's the software revenue? And I think we think that question over the rest of this decade is going to be answered emphatically with a tremendous increase in productivity, changing the way that we work, and changing the way a consumer approaches many things of their life, whether it's personal productivity or how they go about shopping, et cetera. We're seeing that now from several companies kind of unveiling their vision. But the hardware cycle is still happening as we train these systems that will then power these, ultimate products and services. And all in, I think how we size at least the enterprise opportunity is that these, AI systems that are increasingly more agents that are executing a wide variety of long duration tasks that act kind of as a pseudo drop-in knowledge worker, will be able to make every knowledge worker a lot more productive and potentially replace some categories of knowledge work. So if you look at the global scale, there's about 1 billion knowledge workers that by 2030 will be getting paid $30 trillion of wages. And we think that software could significantly augment everything that they do, to the extent that enterprises would be willing to pay about $13 trillion for this AI-enabled productivity. And that I think it's very much like the early innings of the internet, where you can't say exactly where every single dollar will accrue. Like you couldn't predict social media and the gig economy and Uber and all these things. We're starting to see early hints of it, like software development, for example, or agents that can function as kind of call center staff. But we think kind of overall it will increase productivity, 2 to 6 times by 2030.
Yeah, like recently there was, and I'm not even sure that this is a true rumor or just a pure rumor, but somebody was saying, oh, the next GPT model from OpenAI will price at $1,000 a month. And I was thinking about that and I was like, well, there's a big difference between $20 a month, which you pay for ChatGPT, and $1,000 a month. But if $1,000 a month represents a tool that's not just a tool that I have to actively work with or use to augment myself, but is instead a tool that I can turn on to achieve a task that goes off and does that task and brings it back to me, like would happen with an intern or an employee, then actually $1,000 a month might be quite cheap. And what tickled me about that as a rumored price point was if you take that billion knowledge workers and you charge them $1,000 a month each for an AI assistant, you end up at 12 trillion, so almost the 13 trillion that we're forecasting. And so you can imagine that as these AI assistants become more capable, actually that is a price point that enterprises would be willing to pay given the productivity advance that they'd expect.
Yeah, in many ways, I mean, depending on how you're using a system like ChatGPT, $30 or $20 a month feels very low. If you have a software developer that's making $100,000 plus per year, and they are literally, you give them a tool that they cannot go back from. Like once they have a coding assistant, it's like, I'm not going back to writing test cases and debugging on my own and iterating so fast. They're getting way more than $30 of their, time value out of that today. And the systems are only getting better and better over time. So the monetization rate on that productivity should increase, I think.
So how does, just to set up the conversation with Labelbox, how is data labeling helping to make these systems better at this point? What did you learn and take away from that conversation that you thought was most interesting or insightful?
I think one thing from kind of their business's perspective is that they've gone from kind of low-skilled data labelers to very, very high-skilled. So taking, let's say, high school level education in the early days, labeling images, to having Ph.D.s in math and science, writing or organic content to train these systems. And it's not all happening in the kind of pre-training phase, which is basically the gather as much data as possible. It's happening in the alignment phase. So post-training, doing what's called RLHF, which is reinforcement learning from human feedback. They're having PhD level individuals create that human feedback, which helps align a model to the preferences of the end user or what the modeling company is trying to get after. So I think that it's interesting to observe kind of that change in the market and how kind of upskilling the very simple tasks, the models are probably better than humans at identifying stop signs, or at least they can do it much quicker and cheaper now. So we don't need the humans for that anymore. We're having the very high skilled humans do much higher skill tasks for the models.
Yeah. I mean, it's really going from probably literally pennies or perhaps micro pennies per label to $1,000 for a label.
Yeah, that was a crazy number. Yeah, that was a crazy number.
Yeah. So we hope you enjoy the conversation. It's really fascinating. It gives you a taste of both kind of how Labelbox has changed over time and the needs of data manufacture has changed for these models over time, and how the industry as a whole is changing at the foundation model level. So thanks for joining us and enjoy the interview.
So I was looking back and saw the last time we had you on our podcast was October 2022, which is 1 month before ChatGPT came out. And a lot has changed since then. Would love to hear how your business and your industry has evolved over the last year and a half or so.
Yeah. Oh my God. What a last 2 years or so. A lot has changed in how AI is built, right? So before ChatGPT, most of the companies around the world, most of the enterprises around the world were in this pursuit of building all kinds of AI models for improving their business functions, powering their products and so forth. But post-generative AI, what we have seen is that most of these companies are rather renting intelligence from these foundation model companies. And what I mean by renting intelligence is that they're essentially plugging in these powerful capabilities of these foundation model providers, OpenAI, Anthropic, Gemini, and they're powering all kinds of things in their businesses. It's one of the fastest ROI I've seen from outside in. Into these enterprises. And then we've seen kind of a new class of use cases emerge where these enterprises are kind of fine-tuning or customizing these base models to unlock even greater capabilities that were not even dreamt 2 years ago. And so, it's such a powerful and tectonic shift in the behavior of kind of how AI was going to be built and AI is being built now and consumed. in our business, we are the data provider for AI companies, for AI builders. And we see that quite distinctively in a sense that foundation models of all kinds uses a technique called RLHF, which I think is very, very widely known at this point. And it is uniquely different in the sense that it's not a supervised labeling that we would see in deep learning models. However, in the same breath, I could say it's sort of the same concept, which is expert humans are helping align these models with the preferences. And instead of having people from, let's say, a high school kind of level complexity, now people are Ph.D. level or extreme extreme skills in languages. And these are the people who are training these foundation models through RLHF. So that's a class of what's happening in the kind of foundation model land, where companies, let's say 10, 25 companies or so, some of the biggest generative AI providers, they are heavily relying on RLHF, and the rest of the enterprises are taking these models and customizing it. And, they don't have to necessarily go through billions of dollars of investments in building these models, and they can use these big models to synthetically generate data and distill into these smaller models, which is just the right kind of footprint for whatever the operating conditions are, and they're putting that to use. And so what Labelbox has become is kind of a data factory where all these years we've built kind of an amazing world-class platform, software tools for these enterprises to train these smaller models, task-specific models. But now we are powering, most of these foundation model providers behind the scene with the data that our factory kind of generates. So we basically use our own platform and powered with what we call kind of an expert network. We introduced that called with Aligner, and we are basically operating an internet scale RLHF platform powering kind of the data and these foundation models. And so in a sense, we have adapted to kind of this post-ChatGPT moment. And those are the kind of two distinct things that has changed for our business, reflecting kind of the changes in the broader market.
It really seems like, it's kind of I wouldn't have predicted beforehand that we would go from a spot where we were doing data labeling for the data that would feed into the training regimens of the models to taking outputs from the model and then essentially applying human labeling to the output. So for one thing, it seems like maybe we had to do that because the data volumes going into the models exploded. We're using 15 trillion tokens. We were never feeding that much in. And it's kind of like an interesting direction that things have moved. Do you think that having human feedback on the post-training portion of the models is going to be a position that remains in the value chain, or are you going to have to move further kind of upstream or into validating models as they're operating in the real world to make sure they're still aligned? Or how do you think about kind of the next evolution and kind of data, call it creation for these model providers?
I think that's a very interesting kind of topic of study. Most of the researchers in these labs are every day waking up to think about how they more effectively going to align these powerful, ever increasingly powerful models. I think that alignment is going to be something that we're going to need for a long time. And then the question is, how is this alignment really done? And, I would, when you look at kind of these broad-based AGI kind of pursuits, these systems have to be ultimately preferred by the users, the humans, and the human preferences changes, and so I think there's probably got to be some ways to close the loop where human preferences are changing. These AGI systems have to provide more value to this to these user groups, and all the demographics across all the countries, and somehow that feedback has to be channeled back to the model, and so the model can be more in tune to what the people want. And so I think that if I were to make a bet, I think that is likely gonna be here to stay. However, with that said, I think there is really smart strategies that are being employed to create more data. And what I mean by that is, in pre-training, of course, there's the internet. That's that, and we're companies are tapping into private corpuses of information by all kinds of deals or partnerships that they're structuring. But what we are starting to see is that teams are starting to use LLMs to generate more data. So, a very promising technique that I think is totally makes sense is you can access new corpuses of information and have a tool use LLM, uses a tool like a RAG and creates more data. And so I think we are seeing that it's becoming very effective. And similarly, there's a similar kind of trend that we're seeing in post-training, where variety of aspects of post-training can be now augmented with just smarter techniques, where you don't have to necessarily rely on humans, and humans are doing much more effective alignment work. So I'll give you a tactical example. So just last year, supervised fine-tuning, which is one of the post-training steps people do, foundation model providers have to go do, it was basically human-driven. And now, supervised fine-tuning steps can be mostly automated. LLMs can actually generate a really good SFT data sets now. However, they're not as so good in creating preferences, because preferences are, I think, innately human kind of concept. And, ultimately, these chatbots, models have to increase engagement in all kinds of demographics. It has to become more useful in all those new domains. So these models have new capabilities. It can do data analysis. And it's now starting to do some agentic workflows. And that is new frontier, which is best aligned with human preferences.
So one way I think about it is, as in, they're the foundation model companies, and of course those are, call it preference aligned. Conceptually, somebody could take, I don't know, a meta model like the Llama model and say, hey, I'd like the off-the-shelf Llama model, but I'd like it to have to really like Nike shoes. And then they would hire you to do kind of the reinforcement learning to basically have the model persuade people to buy more Nike shoes than Adidas. And so it could be like a advertising model built on top. Is that something that is actually practically implementable, or is this just I've created this thing in my head and that would never possibly happen?
Anytime a model is being customized to a narrow domain and it needs to achieve a superhuman kind of accuracy, what I mean by that is it has to perform across all the dimensions that the creators care about, far beyond what the base capabilities are. It requires data, and basically there's a proven recipe at this point. You take a base model, apply whatever the business problem that you want to solve, and translate that into what data you would need to improve the model performance in that direction. And yes, the forms of that data would be preferences or supervised fine-tuning examples. It could actually even be ground truth examples that you might want to put into a prompt for in-context learning, right? So the data is kind of in variety of variations that you put around on the model. Some use cases you don't have to change the weights of the model. You can do in-context learning, becoming very effective in certain use cases. But in many cases, you've got to change the weights of the model, and then you have to go through this training regime, which is with SFT or RLHF.
You made me think of, I think it was Anthropic put out a research piece of how you can it's kind of hard to interpret the weights of the models and which weights are active for which type of questions. And they found, you could identify weights that are active for certain keywords. So like, I'm going to make this up, but it's something like the Eiffel Tower. And they amplified it so much that every question you asked it mentioned the Eiffel Tower in every response, and like somehow found a way to shoehorn it in. And that's what I picture as a method to do the Nike example.
Right.
I don't know if it's going to be effective, but
that analogy totally holds because we've seen companies and teams develop characters in games, and developing characters in games requires a very nuanced kind of role playing. That is, again, you can basically do that with that data, like for whatever that context is, whatever the gameplay is, and the personality you want to bring into that character. And that is no different than your analogy of Nike.
You mentioned model distillation, and I think Meta, when they released Llama 3 or 3.1, for the first time changed their license so that you can actually use the large model or whichever model you want to distill your own models from it. Could you talk a little bit more about what that process actually looks like? Like, I envision it, like why companies don't have it or model companies don't allow it in their terms of service is because a company like OpenAI is spending potentially billions of dollars gathering all this data and training a model on it. It's a lot of compute and intensivity. And then there's a way to basically extract all of that training data from the model itself by asking it different questions and basically reverse engineering the training data set. So OpenAI doesn't allow you to do that, but now Meta is allowing you to do that. How is that kind of changing things? And maybe how does the process actually work on a more lower level? Because I think I understand it in theory, but not in practice.
I think it's one of the most wonderful things I've seen in the industry. Kudos to Mark and Zuckerberg and the entire team to making that to doing that. So generally speaking, the intuition, or kind of a simple way that I describe to people, is if you're training a smaller model, it has its inputs. There's all kinds of ways you can ask questions to a model. It could be very structured. And there's all kinds of ways the model can answer the question as well. It could be a single line, single word, yes, no, or it could be multi-turn conversation. And for a variety of use cases, you want the model to be just super simple response, like categorize this into one of these categories, or provide the answer in one sentence or less. And it might not make sense to run like $500 billion parameter model for a simple use case like that. And so what people do is, let's say, okay, I want to train a much smaller 7 billion parameter model. First, these teams will go and find out or create as many variations or questions that people can be asking, or in other words, people will look for reflection of their production data that they will see in that particular use case. And they'll feed that prompts, all kinds of those prompts, into a bigger model. And the bigger model creates all these answers, responses. And, sometimes the responses have to be tweaked. And you can bring some human supervision in there to ensure the responses are just right. And then you certainly have a prompt response pair that you can then use to train smaller models. And so this is a very proven technique now. And in fact, we actually were one of the first companies to offer this in a platform in a totally self-serve way. So today you could go into Labelbox and easily synthetically create data sets for a smaller use case. For a small task-specific model use case, without any training or skills. So, so that's generally how the use case works. It's basically giving all sets of questions, asking one or many big models, collecting those responses, synthesizing those responses in exactly the way you would want it to be, and then taking the data and training a smaller model. That's distillation. It could be, in many cases, it's fully automated. All you need is a library of prompts. And in some difficult or tougher, nuanced use cases, it's much more augmented with humans in the loop.
The reason to do it is to end up with a model that is cheaper to infer and has lower latency at the end that can answer those questions. Is that like ultimately you're going for a small parameter model because you want it locally hosted, or you just want to be able to inexpensively run it for end users, right?
Yeah, that's right. And I think there's a really interesting development happening in the industry, which is maybe, all these models had to get bigger only to get smaller because initially all these labs are trying to, in pursuit of AGI, we're trying to kind of compress all the world's knowledge. And the way to do that is to have lots of parameters, lots of compute. And once you have this gigantic model that basically has all the knowledge, you can then kind of optimize it by distilling it into a smaller model. And it is, very precisely giving all the answers to the questions that, humanity asks for. And the underlying, the resulting model is much more efficient. And I think that's what companies like for example, Gemini 1.5 or that came out with, initially was a very big model, but then they came up with Flash. Flash is the distilled version from the original bigger model. I believe it's the same thing with OpenAI GPT-4 and 4.0. 4.0 I think is much more smaller.
Yeah, I like that analogy that we're getting better and better at compressing over time. Like already I think of, you have the world's internet data just as the starting point, and you're compressing that into weights that the model can then use to reproduce, information from that training data set. And over time, we're getting better at doing that compression. And to do it well, you might need to do a very large model as an intermediate step to then train your smaller, more efficient model from that large model, or distill it from the large model.
Well, there's also another thing, or call it interesting curiosity, where it's that the data that we feed these models is co-entangled with some kind of information about how to think logically and reasonably about things, right? Like the fact that the models can do code so well is kind of interesting. And in fact, it's really fascinating. And that they have stumbling blocks in basic like spatial logic puzzles. And so one of the directions it seems like OpenAI is going is, hey, can we distill out some of the data that's in there? It's like the fact that I can ask GPT-4, like how many internet users were there in 1999, and it gets the number right that's in a database somewhere, even though it's not looking it up, is actually wildly wasteful. Like that's not the way your human brain even works, and so is there a way to retain the logical reasoning while stripping out all of the data which would be better off accessed in some kind of external data store? And then from the Labelbox perspective, it's like, do you think that the preference data that you all are providing or basically the fine-tuning is a lot of it, is it kind of like, I need the world's best expert at biology to make sure that this model has memorized all the biological facts? Or is it more like, I need somebody to make sure this model is operating logically? Or are they both categories that are just, different parts of what you do?
Yeah, we certainly do both parts of it, and I'll explain in a bit. But if I think about what would be the shape of these even more powerful AGI-like systems, I currently believe that it's going to be a compound system, a compound AI system. Like there's a reasoning engine, there is a completely different system, like something like Wolfram Alpha that that can do maths, and then there is something like then there's LLM. And, then there's retrieval or tool used to access world events or like real-time information. And it's probably going to be something like that rather than a single model that can just do everything. I think it just makes sense to me because it can, in that architecture, it appears to me that we can solve some of these shortcomings of current LLMs much more effectively. So we have systems that can do mathematics really, really well and very accurately. And we have LLMs that can do other things really well. How do we combine it together? We have all this real world information that the current affairs and so forth, and that's a tool use. It doesn't make sense to always embed that in every model and training, right? So I think something along those lines is likely going to be a kind of a promising direction or potentially architecture of the future advanced systems. There is actually a lot of human supervision goes into like these broad-based systems that are deployed across hundreds of millions of people. So one is, let's say if you're building a search system, right? So this is a generative AI search. Now these search systems, it has intrinsic flaw, which is these LLMs will hallucinate. They will not be factual. They might give you wrong, like incorrect summary from those 10, 20 links. And so a lot of times companies have to have human intervention to do factuality correction to ensure that these models are factually correct. And that feedback, that signal is used to, again, fine-tune the entire system. So that's, that's one example for a compound system where human supervision is needed. It's not necessarily preferences, or you could call it like sort of human supervision journey for alignment. Then, of course, there is kind of a consumer chatbot goes into, let's say, a new country, let's just say like Brazil. And there's just so much nuance of, the culture and how things are done there and what is preferred in that demographics. And that is, again, that requires preference, that requires working with humans representing that geography and that language and that nuances of that culture to improve the underlying system. But at the same time, you kind of want to optimize the system so that it doesn't degrade the rest of the other systems, because again, usually these are, a single giant model. And so it's a very multivariate optimization challenge to continue to make these systems really compelling and across all these different, domains and geographies. Some people, let's say, want the LLMs to do, college level exams and maths. And on the other hand, someone in, Brazil wants to just know what's the best thing to buy or to eat nearby in that region. And so trading, all of these things are getting it right and getting it engaging is a very difficult problem. And it's all at the moment done with, all kinds of this smarter optimization and preference tuning systems. All of these gains are coming from post-training at the moment.
How do you train for planning and reasoning capabilities? Like factual makes sense. You just need to have the facts in the training data set and, a lot of similar facts for one topic, and it will be good at answering questions about that topic. But how do you actually make a model better at planning? And the example that I heard recently was, you can ask a coding agent to build you an accounting system, or you could try and ask it to build you the world's best accounting system. But like, how does the model actually know what makes a really good accounting system and how to design the web interface and the backend server? Like, how do you actually train that capability?
I think that is an active area of research. I've seen some different varying approaches. I think one school of thought is that there actually is not enough reasoning data on internet, and internet is a reflection of basically outputs or synthesis of the reasoning. And I'm sure there's nuggets of reasoning insights on the internet, like trillions of tokens, but it's not enough. That's one school of thought. That means like, well, we gotta go invent reasoning data. We gotta go manufacture the reasoning data with all the tools and techniques we have at our disposal. Then the other approaches are like, well, maybe the reasoning engine takes a form of something like, what you saw with the recent DeepMind's maths breakthrough, where, they have a system that got a silver medal, I believe, in a math Olympiad. And it is searching for all plausible scenarios and then picking, I think, the right one. I think that's my best understanding of how that system works. So, I think that's few examples that I've learned to see on our platform, and I think it's a very big active area of research. If I were to make a bet, I think it's going to likely take some sort of a hybrid approach where we're going to have kind of these search capabilities in the model. that will think through all plausible solutions and try some of them and see how far it gets. And there's some sort of a implied kind of a optimization where when it gets the answer, there's an implicit function where just like when it gets the answer, it just knows that that's likely the right answer. And it, outputs it to the user. It might take more computation to do it. So like, again, all of this school of thought means like, the inferencing is not instant. Right now, you're basically expecting an LLM to just regurgitate, answer right away, like no matter what difficult question it is. And maybe, with these advanced algorithms that we are working on, maybe the LLM takes a minute or two to respond to you because it's going through all of these variations and testing hypotheses and formulating the answer before it gives it to you. So I think, so that's very promising direction. Again, this will require new kind of data to validate these models, to fine-tune these models. Again, that doesn't exist as much yet.
So we've talked a lot about language. If I recall, when we first spoke to you, I think it was really labeling images and feeding into some of the image generation or image classification models. This is back, 2019, perhaps. But like when you were talking about, call it localization of models to specific geographies and cultures, that called to mind to me, like, oh, it's just like driving. Like Tesla's not going to be able to take its driving model and dump it into India and expect it to perform, right? And so do you think that, and this is a kind of like a broader question about direction of travel from models, just the stuff that's happening with language and into imagery, into models that are deployed on real world assets. Do you see a kind of, call it data manufacturing opportunity for Labelbox in kind of these real world applications, whether it's like, are you going to have people that are teleoperating robots to train robots and that kind of stuff? Or is that outside of the scope of your business? And do you think that it's going to be an area that's like a growing area for kind of data creation?
I think that's very fascinating. I think that's a good idea. We certainly will be open to it when the time comes. I think that's right, which is deploying these models in a new territory, which just works very differently than, let's say, where the models are created for or intended, like let's say in English. They do require customization. They require optimization to perform really well in that new territory. And, we see that, for example, like Labelbox has the fastest growing expert community. It's called aligner.com with double R. And people from all sorts of different countries are signing up and contributing to the training data or evaluation of these models in different languages. And these individuals are, fairly skilled. They have bachelor's, master's. Sometimes they are actually linguists, and so and we can see that the latent demand is that the foundation model companies, when they're operating in new geographies, new domains, they do need that feedback to optimize the models. I think it's no different than like Tesla going into the new countries and making sure it's optimized. I'm sure it's probably the same thing when they have to change the platform from Model Y to like Cybertruck. They're going to have to do some sort of fine tuning or optimization. It's not going to be a lot, but it's going to be a thing that you're going to have to do. And so, but the beautiful things about some of these companies is that they have a closed loop system. Like Tesla, for instance, has it's an AI complete problem. The more vehicles they have in, let's say in India, the more data they'll have, and they'll be able to kind of process it, use it to train their models and deploy it again. And same thing is happening with the chatbots or the AI assistants. Yeah, the more countries they operate in, the more data they're collecting, and they can then use that production data to figure out where the engagement is low, and then work on that area with more preference data, more fine-tuning data. So I think to answer your kind of initial question, I think the paradigm here certainly is that humans are demonstrating in some way or the other what they like and how things should be done. And in the physical world, I think it's going to be really interesting. Like, what form will it take? So far with robotics, we are seeing, there is quite a bit of overlap with kind of these multimodal models that are trained on internet data. They can actually help navigate the robots in indoor or outdoor environments because there's a kind of base knowledge that helps that to do basic things. But then to truly do tasks in a, let's say, warehouse or, in the real world, maybe there will be more real physical world demonstration data needed to truly get to the kind of the final last mile.
Maybe an interesting question to end on, which takes us all the way back to, I think, how you answered, one of our first questions. I think you said, you're seeing with generative AI, one of the fastest ROIs ever. There are, some people that debate that there's a lot of actual ROI happening. Like Sequoia has a recurring blog they're now calling AI's $600 billion question, which is the difference between, NVIDIA doing $100 billion in data center sales this year and the relatively smaller number of companies that are reporting, multi-billion-dollar sales in AI products. So the AI software is lagging the AI hardware. Where are you seeing ROI, and where do you think the biggest pockets of value are going to be created?
I think both are true here, which is, the productivity is where where most people are finding great value with these LLMs and these AI assistants is productivity. Our entire company uses AI assistants, whether it's for coding, whether it's for writing, go-to-market functions. All of those roles are boosted, augmented by AI, and certainly it's the case in the enterprises as well. People are using AI assistants to make their workforce more productive. They're able to search. They're providing new systems to search the entire company corpus to make decisions faster and so forth. And I think, you're seeing with companies like, you guys are big investors in Palantir, the systems are the LLMs and AIP systems. They are really powering end-to-end big workloads and workflows in the enterprises and big decisions too. So I think it's there for sure. Now, is the level of productivity gains or is probably not seen as much from a Sequoia point of view, in dollars and figures yet. And I think that's also right. I think there's a tremendous amount of investments being made across the data centers and all that. I think I'm on a camp of, when I listen to Zuckerberg or Sundar, that the risk of underinvesting is a lot higher. The upside, is there in over-investing in this deployment of AI infrastructure. And, if foundation models stopped kind of innovating now, which I don't think they will, but if they do, I think we'll still be able to use a lot of this deployed infrastructure because it will take some time for these models to be refined and tested and put into, all kinds of workflows in the enterprise or broader humanity. And, but yeah, I think it's, the level of investments are certainly very high at the moment, and I think we should see that in the next few years, how that pans out. We are, I don't think we would want to go back from where we are today, in the sense that we use all these AI assistants in everyday job. It's pretty remarkable that, we can create videos and images and make slide decks that would otherwise take weeks. It's now taking a couple of days max, and tasks that we would never write in our software are now getting written with the AI assistants. And so, so there's all these kind of things that are happening, which is amazing, and it's certainly very valuable.
There is an interesting, even talking to people that actively use AI assistants to those that don't, and there's a lot of people who don't, which is really fascinating. A lot of people whose work functions would be really improved by it. And so, in some ways, I think it's because the capabilities of these systems are extraordinarily poorly documented because we don't actually know what they're capable of. And so it's unlike traditional software. I ship it to you and it has a menu with the things it can do. And I was like, oh, this function, this is something that's useful for me. With kind of like these AI systems, they really, we're shipping software that the people who develop the software don't know what's on the menu. And so there's a whole kind of discovery process that's going on inside enterprises of like, how can this be used? How can it not? And that discovery process has to look very different from how typical software is qualified in and deployed. And so I do think that there's there's a lot of companies and individuals and C-suites like grappling with exactly what this is and how to use it. And it's undeniably valuable. And you can imagine how that will result in at least kind of like bumpy kind of adoption curves all along the value chain. And like from our perspective, it's like you could underwrite or you can get an ROI on the NVIDIA chip spend just if Tesla's robotaxi actually comes to, like, it might be that most of that capital is wasted, but then Tesla's is actually very good ROI and such exceptionally good ROI that it makes up for all the other losses. I don't think that's actually how it's going to play out, but that's like another solution to the puzzle.
And just to that, like riffing on that idea, I mean, like let's say those humanoid robots work, which I think I think one of the reasons why humanoid robots or all this robotics is kind of taking off right now is confluence of these LLMs that have now become good. They have become multimodal, which required more compute, and now they have to get distilled and smaller so they can be fit into these, robots that are powered by batteries. And so, like, let's say if that wave takes off, like that in itself probably could have like tremendous output in the world, right? So I think we are kind of still in the early innings, but I think it's certainly very fascinating, and it's probably not going to get wasted. I think we're going to end up with generally net better world, and we already are.
Great. So Manu, where can people learn more about Labelbox? Where should people go if they need to align a model?
Yeah, come to labelbox.com and try our software or just speak with us, and we'll love to share more.
Okay, well, thanks so much for coming on the pod. We enjoyed the conversation, and we'll connect with you, in whatever the next version of models is in a few years. Okay.
Awesome. Thank you for having me.
All right. Cheers. Well, that was a fascinating conversation with Manu. Thanks for joining us on FYI, the For Your Innovation podcast. Please like, subscribe, and leave comments on whatever podcasting platform you use. And I suppose if you have data alignment or labeling needs, you should go to labelbox.com. So thanks for joining us.
ARC believes that the information presented is accurate and was obtained from sources that ARC believes to be reliable. However, ARC does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARC. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARC's current views and assumptions and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.